What does environmental conservation and sustainability mean? I think it's based around energy, the use of it, the production of it, the understanding of energy. It's all around us. It drives every aspect of our life. Whether we realize it or not, we use energy constantly, every day of our lives. Whether it's things that we plug into the wall, the food we eat, the cars we drive, even staying warm or cooling ourselves. To discover how I personally use energy in my daily life, I wanted to do an energy audit. I felt like discovering how much power, how much fuel, the food I eat, the clothes I wear, how that affects the amount of energy that's consumed. This power strip is just devices plugged in. They're not charging anything. They're not hooked to the actual device. If you can see, this little nice handy meter is measuring the parasitic power, just the standby power, almost 1 watt for the toaster. One side of, so when you toast, you're looking at about 750 watts of usage for a normal toaster like we're seeing here. This lamp has an incandescent light bulb, 55 watts. And, the meter shows 57.4, so I mean pretty close. A little bit of a watt usage inside, the wiring and mechanism. Now, most of the lamps in my house are these LED bulbs. It's supposed to be about 6 watts, and it looks like it's just under. Bounce around from about low 5s to 6. So all these can lights, a few years ago used to be incandescent bulbs. These are all LED bulbs, rated at about 6 watts a piece. Same with the light over the table there. Now, kind of get an idea of how much power I use, electricity I use. So just the toothbrush, not even a half a watt, so not very much. But it takes about all night to charge, so it takes a good 10 hours to charge. So that the charge time is long. Tablets, the little chargers don't really pull. It took about 4 of these little chargers to get about 1 watt without anything plugged in. And plugged in, the devices averaged about 4 watts or so. Laptop, same thing. The power supply didn't really pull much power, just sitting there. But once it's plugged in, the battery is fully charged on this, so this is just the power used to run the laptop, anywhere from about 17 to 21 watts. The flashlight charger standby was 2 watts, just plugged in. And once I was able to make it work here, once again back up to about 4 watts. This flashlight has a lithium battery in it, just like the tablet and the laptop. It's bounced up to about 9 watts. Now the TV was interesting. It on the back it said typical about 60 watts. This is a new Samsung. It's only about 3 months old. So typical usage, it said on the back, about 60 watts up to 120, up to 150 watts. And as it starts up, it's just right below 40. It's hard to see the decimal point. And as it gets going, it'll get up into the 100 range. So this TV will pull over 100 watts typically as you watch your normal show. just an idea. So every 1,000 watts that you use per hour, so they kind of rate it as kilowatt hours. You can see it's about 116 here. We'll put out about anywhere from 1.2 to 1.6 pounds of CO2 from generating that electricity. Typically, depends where your power comes from. So 10 hours, just under 10 hours of watching TV, you'll put out about 1.5 pounds of CO2. Now, food was interesting. Food, you have the food here, so this is beef. And the real issue with beef is how much water, about 15,000 liters per kilogram of meat to produce beef. Fruit, same thing, a lot of water is used, and transportation costs for your food, so you have emissions through transportation plus the agricultural part. It uses super energy intensive. Bananas are one of them. Breakfast, oatmeal, I mean, once again, the packaging, the shipping, the processing, it all adds up. Your food consumption is a big part of your energy. And one substitution, so like chicken uses quite a bit less resources than, say, beef or pork. So for energy substitution, chicken is a good alternative for things like beef. And devices that use power, the microwave standby power, about 20 watts standby. The double stacked ovens here are both electric. And then the range, the stovetop, is gas. So all these burners combined will put about 55,000 BTUs, which for natural gas you're looking at about 100,000 BTUs per hour. Will give you about 117 pounds. 1 million BTUs will be 117 pounds of CO2. Another big energy thing we don't realize is water. So water pressure, conserving water. Water takes a lot of energy to clean, to actually retrieve for some places. Cities, towns, or even homes ran off wells, so you're pumping the water out of the ground. Most don't have natural flow. And big cities have, banks, massive banks of water pumps. You can see here, each one of these water pumps is 200 horsepower on the upwards of 60 kilowatts per motor you see here. So, and these run continuously for big cities. And these will either put the water into above ground storage tanks like this that you see. This is pretty typical for around my area. My house is ran off of a well system, so we have our own storage. Or you might be familiar with the water tower, so the water has to be pumped up into these. Send the same system. Usually those pumps are running continuously. And it's kind of a vicious cycle, so we use water, our waste water from toilet sinks and everything. It goes through sewage treatment, and then it eventually ends up right here in the river. And we spend a lot of time and energy to clean the water good enough, because we actually discharge the wastewater usually right into rivers or waterways, typical of this one. Transportation was my biggest consumer of energy. Even the motorcycle, this gets about 60 miles a gallon, but you're still looking about 19 pounds of CO2 per gallon of gasoline. My other car that I use gets about 40 miles a gallon, but so you're still putting a lot of CO2, and then that's just the gasoline itself. That doesn't account for producing, the gasoline from crude oil. So typically, this tank represents about 300 gallons. That's what I usually use in about a year for my normal personal use. this big tank, about 12,000 gallons. This is about what I use at work for the helicopter. And for my car, usually my yearly CO2 output is about 4,000 pounds of CO2. So it's about 2 tons of CO2 just from my automobiles. The other, doing an energy audit for me, the other thing that, my food is probably about another 4,000 to 6,000 pounds of CO2, another 3 tons, according to the calculators. Now, the interesting thing that I love about energy is people are always finding new and better ways to produce it, more sustainable ways. And people are probably familiar with semis, big diesels, noisy, a lot of black smoke, things of that nature. You can see this one just started up. And you can visibly see the emissions. And diesel has a higher CO2 output as an emissions than gasoline, about 22 pounds per gallon of burnt diesel. Same thing here. Things like these semis, they can average anywhere from about 2 to maybe 7 miles per gallon for the most efficient semis loaded. So you can imagine the semis don't make up the major part of our transportation, even though you see a lot of them. But their emissions, because they get such poor mileage, they do put out quite a bit of CO2 emissions.
Being in a company like this, especially this early on, you tend to wear a lot of hats. So that ranges from HR to our company's insurance to project management, even some marketing stuff, business plan, financial modeling, all sorts of stuff. I either handle or am a part of all those
Tony's
areas.
talking about, he works for Nikola Motor Company, and they're building hydrogen-powered semis. This is a rendering of one. They've built a couple prototypes so far. They plan in the next few years to have these on the road. And they run off hydrogen. And their idea is to produce hydrogen on site. So they're looking to be 100% green, zero emissions from the beginning to the end. And this technology, it doesn't only fascinate me, but it's going to be a revolutionary because it's going to transform the transportation industry.
I'm the project manager for our UTV project right now that's going through alpha development.
So this is the Nikola Zero. This is their test bed prototype. They're kind of scaled down the stuff they're going to put on the semi into this side-by-side ATV, UTV. And it ended up being very popular. They're actually going to produce these and sell these as well because of the positive response.
The Nikola Zero is a pretty cool project because we took the technology on the truck and kind of put it onto the UTV.
This is what Tony's talking about, the UTV, the Nikola Zero. The semi's called the Nikola 1, and they're doing a Nikola 2, which is a day cab version of the semi.
And it is directly relatable to our truck. It allows us to get a lot more miles in testing on it. It's a lot smaller. We don't need to get certifications to drive that on the road. There's a lot of things that we don't need to do necessarily because it's off-roading, it's doing whatever. It could be on proving grounds, things like that, where you can't necessarily do that with the truck.
So I think the key point of their whole business plan is these hydrogen stations, 100 megawatts per station, solar farms, or wind for areas that support it, Midwest especially. And they'll have on-site conversion, which saves a tremendous amount of energy and time. And obviously this allows for other opportunities for passenger vehicles. The passenger vehicles will be able to buy hydrogen from these stations, which is the difficult part at this moment in time, is where do you buy hydrogen? There's very few places that sell it. So it's not real big demand.
Hydrogen is very expensive, in part due to in part because you have to transport it. A lot of people don't produce it on site, and you're starting to see some of the stations in California will have small electrolyzers or steam methane reform, which are the two most common ways to produce hydrogen. And but they produce very little hydrogen. It's not, it's a lot for cars because cars take 4 to 5 kilograms, but when you're talking about a truck that needs 70 and is driving all day, refuel, potentially every day, more likely every other day, then you're talking about a massive hydrogen need.
And this is their Nikola 1. This is their main semi. And it'll hold about 100 kilograms of hydrogen. And what he was just saying there, so it gives them about a range of about 1,200 miles. Regenerative braking, so there's big efficiencies there. It's all-wheel drive, rated at about 1,000 horsepower.
So there's some creative ways to do it. Our dream and our goal as a company is to produce zero emissions from production of the fuel to the consumption. Mm-hmm. So how do you do that? You would do that through solar. You could do it through geothermal, wind. There's a lot of different ways you can produce electricity with no emissions, with renewable resources, and then use electrolysis to produce your hydrogen, and you do that all on site because that can bring the cost down significantly because you're eliminating transportation costs. And to transport it, you have to compress it, and the amount of electricity that's required to compress hydrogen is absurd.
This is what their 100 megawatt solar farms would look like next to their stations, strategically placed across North America. Over 300 eventually planned stations will go in. And they do a program where their semis, if you lease them, you fill for free. So your fuel is free for the first 1 million miles. So solar is going to be the big one. And then wind, they'll also do wind power is very abundant in many areas across the United States. So there'll be a mixture of ways to generate the electricity for these on-site hydrogen stations.
That's one of the unique things about our company is we're a startup. It's not a big, massive automotive company that is just dedicating an R&D arm to start a new technology or kind of test the waters. This is our product, this is us. We're clean energy vehicles, zero emission vehicles. And so you run into a lot of roadblocks with that. Obviously, it's just growing pains, various growth problems relating to those. And you don't have the capital that a lot of the bigger companies have either, where they can deploy $1 billion, so to speak, to a new project where we're not able to do that.
This is their goal. They want to transform transportation. They want to get it away from fossil fuels, finite amount of resources, to a sustainable, renewable resource, solar, wind, geothermal. And that's an amazing goal, amazing optimism they have. And I'm excited for them. I look forward to the future and what Nikola brings to the...
Regardless of your beliefs in climate change, you should want to make the world you live in a better place. Mm-hmm. So I think that's one of the cool things. That's one of the reasons why I came to work here at Nikola too, is because, at my previous job, you couldn't really tell the difference you were making or what you were doing. Is kind of just doing stuff, but you're not really seeing it materialize into anything. Mm-hmm. Whereas here, you're literally changing the world, so to speak. A lot of the technology and stuff we do could apply to passenger cars, garbage trucks, cement trucks, tractors, all sorts of things. endless possibilities that we aren't even beginning to tap.
In my little world, I want to say their technology will eventually transform into housing, into cities. You'll be able to create these utopias where their entire energy needs are either through hydrogen, or hydrogen is a good storage media because it doesn't go bad, it doesn't deplete unless there's a leak. So when it comes to producing a difference between hydrogen as the storage or batteries, I would hope that hydrogen will be the future technology.
If I were to leave a message for future generations, it would be to do stuff you love, do something that actually matters, do something you're passionate about, because a lot of people fail to do things they're passionate about. And it's unfortunate because then you kind of skate by in life, where if everyone did what they excelled at the most and what they were most passionate about, I think there'd be a lot more productivity, whether that's in sustainability and clean environment, or maybe it's in teaching, or what. There's all sorts of different occupations, but I would just truly follow your passions.